as we start Unit 9, normally you'd start with 9.1, simplifying radicals. Well, here's the thing. If you haven't had a lot of experience with perfect squares and how they work and what they do, simplifying a radical is going to be super hard. So here's what we're going to do instead. We're going to put the notes to the side for right now. We're going to immediately jump into the practice here because this is going to give us a great opportunity to do a little bit of work with just perfect squares and try to figure some things out. So, up here it says square each number, put your answer in the box below it. So here's how this works. If you want to find squares of the, oh, hey, I need to get out of there. Again, if you pop on your screen and it's the middle of a crazy graph, if you hit second and the mode button right next to it, that will get rid of the crazy stuff for you. So square each number. All you have to do to square numbers in these calculators is punch in the number. And over here, like kitty corner from the number 7, where it says x squared, it will not do an x. It will just square the thing for you. And then we can hit enter and put that in. Yep, page 1 in the practice packet, yes. No, we're not in the notes, nope. I explained that a moment ago, but again, if we need to chat again about that at some time, we can. So yeah, page 1 in the practice packet here. And so what we're doing is we're kind of working on making this chart up at the top, which is going to keep showing up in your notes too. And so when I'm trying to fill this up, if I don't know what these numbers squared are, I can just press the number and this x squared button, which is kitty corner from 7, and I can keep getting my numbers. Yes. So for this whole chart, all we're doing is finding the perfect squares of these values and filling in the chart. So I'm going to move this a little so I can actually write as we're going here. And you're like, okay, so what's the point of this? Hardy, are you trying to just give us some busy work or what's the deal? Absolutely not. These numbers that we're writing in at the bottom of the chart are going to be values that we're breaking down when we start doing our simplifying radicals lesson tomorrow. So there is a method to the madness here, and it's also giving you an opportunity to get used to some of the buttons so you know what you're doing when you need them. Instead of being like, Hardy, what do I do? And be like, oh my. So the second row of what we have that I'm going to outline here with my pink, these are what we call perfect squares. These are how we're going to break down radicals once we get to this part. And so part of learning how to deal with perfect squares is understanding what relationship they have to numbers that aren't. So our goal down here in this next part is going to be to find the biggest perfect square that divides into each number. We always want to start with the bigger squares first, because sometimes there's more than one that'll go in, but we need it to be the biggest one. And so we're going to test this a bit. And besides that, we're going to actually get 2 numbers for every one of these. So, yep, here's what we're going to do. So like with 90, let's say, for instance. So I'm like, I'm just going to look at the number next smaller from it, and I'm going to try to divide it in. And if I get a decimal, that's no good. Okay, it's got to go in evenly. So some of them, you may kind of know that it's not going to go in evenly, so you could skip those if you wanted to. But notice, I just keep going down the list here, trying to figure out, like, Hardy, is there really going to be one, or is this just a game? It is not a game. We will find one. And when we do, 9 goes in evenly. It goes in 10 times. I want you to write both numbers down. 9 times 10 is 90. But again, we're going to box in the perfect square. I just want to start. It's a beginning step in getting you ready for what we're going to be doing moving ahead. And so for each of these, what we're going to do, find that number, that next one that's left. Oops, that's not going to help me. It's 4. 4 and 6. So you're like, okay, this stuff's not bad. Because what this is going to allow us to do when we get to the radicals is actually be able to break them down. So that is going to be the goal on this first page. Every one of these will have a perfect square that goes into it. But again, make sure it's the biggest one you're getting, because several of these have more than one. For instance, if I'm working on this fourth one at 32, if instead of going biggest to smallest, I went the other way, I'd be like, oh, 4 and 8. But here's my problem. If I'm going the other way, there's a bigger one. You've got to, when you're dealing with breaking down radicals like we're going to start, you've got to get the biggest one or it messes everything up. So always start with the biggest and work your way down when you're trying to find those radicals. You're like, okay, that's not terrible. That's just a lot of kind of calculator button pressing and messing with things a bit. So here's what I want to kind of change and go with focus on here. What we're going to do is over on the back, okay, there were some things I kind of thought ahead a little bit, but it also gives me a chance to talk about it a little bit more. I had some of you nail everything with the review, and I had some of you that basically left it blank for me. So here's what I want to do to try and, again, refresh you on a couple of things where you can finish the practice then if you're going to retake the quiz or if you haven't taken it, and have another good place to look. Because again, practice makes better. So on the graph, this is the one I specifically wanted to talk with you through, because this is where we had the most issues on the quiz, if I was going to point to one place. So if we're doing that, I wish I wouldn't have taken down my button presses, but life happens. So when we get here, if I want to be able to put this in my calculator, I'm going to press y equals, and you doing it as we doing it and not just watching is going to help you as we get involved with these. Most of your calculators are probably going to have something in it, because my group last hour, we were working on graphing some crazy stuff. So if you're here and there's something there, just hit this clear button above your exponent button here. That'll get that out of our way. And then we can start typing this stuff in. So we get here, there's my 2. That's not just 2 times x, it's 2 to the x power. So we're going to up arrow. That gets us up into the exponent. And right here next to alpha is my x. And once I'm up there, I don't want to keep typing up there, because this plus 3 that I have isn't up little in the exponent, it's down here. So I can right arrow to get back down and do plus 3. Once I do that, it doesn't hurt. I'll take a look at the picture for a minute here. Okay, so first thing, if your graph goes up to the right, that is growth. If your graph goes down to the right, it's decay because it's getting smaller. So you're like, okay, so when are we going to get to the graph part? Just patience. Anybody remember the free square domain, what that is? Yeah, because the reason for that, in case you're like, well, I don't want to just write something down, I want to know what it means. This is our x values. As we go left, forever left, to right. And this keeps stretching out to the right as it goes up. But that's the same every time. My range, there's just a little pattern. Okay, range is my y values from bottom to top. So I see the top. The top's going up forever. Whoops. Oh, I lost it. Come back. Okay. But my bottom, there's two ways I can tell. I can either use my table, second graph, and start scrolling and noticing what value I'm getting really, really close to in y, which is 3, or the number on the end of my equation will tell me where my range starts. So like if this number on the end, instead of being plus 3, was like minus 4 or plus 0 or something, that's telling you the number that's going to be there when you're doing that. And the reason I mention that, and I mentioned the chart, is these last two pieces in the graph are just me taking stuff straight from the chart. So here, when it says f of, it just means, hey, in your calculator, go to that number for x, -1, and tell me what the y value is. Straight from the, you don't have to do anything else on your own. You're just going to take care of that. And then the y-intercept is similar. It just means that the x value is going to be 0. So I keep scrolling, and when I see where x is 0, there's my y. And I've got it. So most of this is just a couple of quick things that we're making connections or using the chart to get to that value. Thank you. Good question. So the thing here is, and I'll show you this when we're doing the graph, the difference between parenthesis and bracket. Typically, you're going to see brackets like if it's a number line, and we're doing this. But when we're doing graphs, here's the difference. So let's get some points plotted, and then we'll explain why that is. So let's see, what can I fit? So I can fit 2, 7. And we can fit 1, 5. And 0, 4. And then I notice this plus 3, where my range starts. Okay, here's that dotted. We've called it an electrical line before, like it's the electric fence. We can get close, but man, we get too close, away we go. So as I'm looking at this, I'm like, okay, so here's why the 3 for my range is going to be a parenthesis. If it was a bracket, it would mean I could touch the dotted line and not get zapped. But with these, I can't. So whenever we're doing domain and range on these graphs, we're always using parentheses. Even though realizing that the bracket could come into play is an excellent thought, but not something we need this particular time. The next two are both problems, so let me put a little box here. Just another tool. Okay, these are our growth and decay problems. The only thing I remember some people having a little issue with here yesterday was remembering that when you get a percentage, okay, before you can stick that in here, you've got to divide it by 100. So I've got my money to start. Okay, so there's my A. When you're getting interest, that's a positive thing. So that's why I'm getting plus here. But my rate, let me clear that out, is going to be 0.03. How much money would you have after 5 years? So most of you, if you got to this point, were fine, but then a couple of you had some issues, but I think I know what that is too. When you go to type this in, what I think happened to some of you is you just typed 5 next, and it multiplied it by 5 instead of taking it to the 5th power. Now, I'll show you something. That's going to be a much different answer than if I go ahead and get that 5 up into the exponent where it belongs. I mean, I know we'd rather have $515, don't get me wrong. But if you're working at a bank and you're the one in charge of clicking the buttons to see how much interest people get, and you're paying them $515 when they should be getting $115, you're not going to have a job very long. So getting that exponent up there is important. And I will say one other thing. I think this word threw some of you for a loop yesterday. Depreciates means it becomes less in value. Cars depreciate in value. Electronics typically depreciate in value. So the only difference here would be I'd still use that formula, but then I'm going to put minus in the middle instead of plus, is all we're looking at with that. Let's see. Party, what do I remember from the quiz? A couple last issues, just a couple. Then I'll kind of let you play with these, or maybe try some of those other things you did before if you feel so moved. These first two, you do not have to multiply these. We don't need big old boxes. If I see a plus or a minus in the middle, I'm just combining like terms. So here, put the things together that are alike. Just add them up. The only difference here is with the minus in the middle, okay, that minus distributes. None of the numbers ahead, just that negative sign is going to change each of these. Positive becomes negative, positive becomes negative, negative becomes positive. None of these, anything changes. So I'm just going to rewrite those. Now it'd be like number 1 would be. Find the things that are alike, and we're just adding them. 7 and negative 9. Negative 4 and negative 2. Again, you're adding. I owe my friend $4. I borrow 2 more. I owe 6. And 9 plus 3 is 12. This back page is a really good opportunity to clean some stuff up so we can start getting some quiz things fixed up and taken care of. Down here, it's all distributing. Put my little 1s on my X's when I don't see anything. And when you distribute, and again, this is on your notes. If you still haven't gotten them, go back and complete them. Multiply the big numbers. Add the exponents. Multiply the big numbers. And if there is no x here, you just take the one that you had at the start. That's all you can do. These are not like terms. I can't do anything with those. And so for the rest of these, we've got examples. But I'll do one. Even though I am going to make mention over here that there's two of these. But here, again, I saw some of you try to do the distributing like a FOIL method, but you'd like lose terms, which is why I'm more of a fan of making a box, and then you just copy each set of parentheses. And then the rules are exactly the same as what we did here. You multiply the bigs, add the exponents, if they both have one. Multiply the bigs. That's the only variable for these two boxes, so I just write the variable down. That's all I'm going to do. Multiply the bigs. That's my only variable. And multiply the bigs. Now, I don't get to just leave the box there. Yes, I did all the multiplying right. That's great. But I still need to combine any like terms that I can. So that's my only term with squared. So I write that down. These two both have x or x to the first. No more messing with the exponents. We're just adding and subtracting. Negative 15 plus 14 is negative 1. And there's my constant term. So that's what we're working on. And most of you did an excellent job on these. So it's like, okay, we're getting the system thing down. That's good. But if you get stuck on that, I'm willing to help too. So again, smart things to do with our time here. I'll rewind this for a minute. Hang on just a sec. Okay. If you still need to get the practice packet in, or you did part of it, but maybe not everything because you didn't know something to do, good opportunity. The extra credit in the back of the packet that we talked about the day before. Or if you want to start working on this breaking down radical stuff, let me know. I'm willing to come by.